Okay, so this is the mock paper 2 standard level, which is actually the May 2013 paper. Okay, data analysis question. We have a lamp which is generating an EMF, and the student is going to vary the distance d and see what the resultant effect on the generated EMF is. In these data analysis questions, the actual physics behind the experiment is not important, so don't worry too much if it's something you don't recognize. Let's have a look at the data. Okay, in the first question, you have a student recording EMF to different significant figures, as you can see there. Oh, here. Okay. But you have the same number of decimal places. Now, from your own experiments, you should remember that the number of decimal places equates to the precision of the instrument. Okay, so that's 1 mark. And your precision is the same because your instrument is the same. Okay, is the same. And that's your 2 marks. Okay, so carrying on, we have now a theory which suggests that the EMF could be inversely proportional to D. So the student proceeds to multiply each D value by the E value. So let's have a look at why he's doing that. We have E inversely proportional to D. Now, if that is the case, then E must be equal to some constant value K over D. Okay? And if that's the case, if you were to multiply the EMF by the distance, it should always give you a constant K value. So regardless of which values you put in, you should always get this number. Now, this is a tricky question. Explain why this procedure can be used to disprove the student's suggestion. Well, if you get your values from the experiment and you put them in, okay, if you don't get K, then, or if you don't get a constant K, then basically you've got, you haven't got an inversely proportional relationship. On the other hand, if these are inversely proportional, the chances that your results are so meticulously perfect that they would always give you the same K value, well, actually, that's actually quite hard to happen. That's why we have error bars. We have a range of uncertainty. So it's pretty likely that you, using the numbers that have been generated in the experiment, it's pretty likely that you won't prove it, even if it is true. And that's why you need to draw a graph. Okay, drawing a graph and working out gradients are much better ways of proving and looking at the likelihood of a relationship. So this is a very tricky question. Part B, using the data D for values 19.1, 16 and 10, discuss whether or not E is inversely proportional to D. Well, this is actually a very straightforward question. It's asking you to carry out the calculation previously mentioned. So it's asking you, right, for 19.1 value times, 5.5 and 16 times its corresponding E value 8.6 and 10 times 37.5. Okay, now if these were all the same, then you would have a constant value, so therefore you would have a proportionality. But in fact, when you work this out, you end up with 3 very different readings. Okay, so you get 2 marks for doing those calculations. Okay, and then your last mark is for saying not the same, so D is in fact not proportional to E. For the next part of the question, we have to do 3 things. We have to plot a data point, have to add an error bar and sketch a line of best fit. So we'll do that next. Okay, so this is our graph. If we have a look at it, what you can notice first is this is a very strange scale, and in fact you end up with a weird scale of 2.5 squares for each 1 unit value. Okay, so you have to be careful with that, and what you have to work out is 5.5, okay, up there, and on here it's a little bit more straightforward, 19.1. Remembering that on this side each square is worth 0.2. So I'll plot that for you. Okay, so our value is approximately here. It's not so easy to do with this app. Okay, we'll try and do a little square there. And you need to use, if you have a look here, you can look at the error bars. It's 1 whole square. Now I can't do this very carefully, but you can. Okay, so you need to make sure that you show your error bar as plus or minus 1 square, 1's whole square. Use a ruler if you can, make it as neat as possible, not like the mess I've made. And also for the next question, you must consider that the value then of the error is 0.2, okay, which we're going to use in the next question. So if I have a look at that, more or less, we now have to sketch a line of best fit. Now, lines of best fit, it's a bit of a misleading term because it can actually be a curve of best fit. What you have to do is have a look at the pattern that you see, and if it looks like a straight line, then it's probably a straight line. How do you know? Well, if it is a straight line, then all your basically your line should go through all points, or at least through the error. The error, which does not happen anywhere, because even if you were to draw a line here, more or less, if you were to, in some way, I think it lets me move that. It's not the easiest thing to do with this program, but if you were to draw a line through these points, this one, and this one, you completely miss out on these. And that's not a good line of best fit. That's unlikely to happen with this kind of question. So what you can see, if you have a look, is a curve. Okay, so I'm going to try and draw a curve of best fit. Okay, here goes. Oops. Oops. No. There we go. Not too bad, okay, considering this app. So you would have to make sure that you definitely don't miss any points like that. Remember, this is a data analysis question, so therefore you need to show that you understand that all lines, curves go through, the error bars. Okay, so now this question's fairly straightforward. Plus or minus 3%, and we calculate the percentage uncertainty in the product. Now, we're multiplying two values, so therefore we need to add the percent. Okay, so we're now on to question 2. This question is about circular motion. So we have a car moving over a hill. The hill has a curvature of 50 meters. Okay, so we're going to think, why is the car accelerating though it's moving at a constant speed? Let me define this very clearly because this is quite a common question. We have acceleration is defined by the change in velocity over time. Now, velocity can change by a change in magnitude or a change in direction. When an object is moving in a circular path, its direction is changing, and because its direction is changing, okay, its velocity must be changing. So if we have a changing velocity, we go back to our definition, then it must be accelerating, okay? It's only a 2-mark question, and you get those 2 marks simply by saying that the direction is changing and the velocity is changing. But I thought I'd give you a full definition. If we go on to the third question, or the part B, sorry, on the diagram, draw and label the vertical forces. So a couple of things to bear in mind. It tells you that the forces are vertical, so that's a good start. Okay, so let's draw a vertical force down to represent the weight. Now, weight must be labelled. Okay, so you can use weight or you can write mg, both appropriate. Now, notice that this must be this is a balanced situation, so there must be 2 forces or 1 large force, but I will write them. Okay, these are our 2 reaction forces. Now, take into consideration the sizes. The 2 reaction forces must show to balance with the weight. So if necessary, you might want to, give an approximate representation. This question isn't necessarily about that, but you do have to bear that in mind. Okay, and then secondly, make sure you label your forces correctly. You will lose marks if you don't do that. Okay, so there's 2 things to consider when drawing forces. Always think of the size. Okay, is it balanced? Is it unbalanced? Which one's bigger? And always label. Okay, always label your forces. Okay, if we go on to the last question. Now this is a bit of a tricky one. Calculate the maximum speed at which the car will just stay in contact with the bridge. So if we think of our car, there is a force that's keeping it towards the centre. Okay, and that's a gravitational force equal to mg. Now, the moment that velocity becomes much greater, then there's going to be, this situation is going to be overcome. So let's have a look. What is the value of mg? What is that gravitational force? Mg is going to be equal to m v squared over r. Now this you should remember because acceleration equals v squared over r. The m's cancel, so in effect we end up with g equals v squared over r. Okay. And g equals 10, so that's the constant that's given by the IB. So try and use that one instead of 9.81. We have 10 equals v squared over 50 meters. Okay, so v squared equals 500, and then your value for v, do a quick calculation. Oh, where's my calculator? Square root 500, 22 meters per second. Now this is the last question in this section. This one's about superposition. Now you have to be very careful with definitions. You can't guess definitions. You have to learn them off by heart. Okay, so what is meant by the principle of superposition by waves? What that means is, why do waves superimpose? Why does that happen? And that happens because when 2 or more waves meet, but 2 will be acceptable according to the IB. When 2 waves meet, their resultant displacement is the sum of all the individual displacements of the waves. Okay, so basically, what is meant by superposition? Superposition happens when you get 2 waves meeting and their resultant displacement is equal to basically the individual displacements of the other waves. It's a lot to say for 1 mark, but that's why it's worth just learning it. Next, the diagram below shows 2 point sources, X and Y. Each source emits a wave of wavelength 1.5 and amplitude A. Now, interestingly, it says over the distances shown, any decrease in amplitude can be neglected. So this idea that the distance, as a wave gets further away and becomes smaller and dissipates and its amplitude becomes less, you can totally ignore that. Its amplitude is going to stay the same. Okay, so this is our arrangement. Points O and P are on a line connecting X and Y. In fact, this is just a description of what you can see. It's fairly self-explanatory. And now it asks, why is the intensity of the sound at O 4 amplitude squared? The bit of physics that this is examining is that you remember that intensity equals, or is proportional, to amplitude squared. Okay, so if we have a think, X and Y, okay, they're equidistant, so this distance is the same. Okay, what is going to happen to the amplitude of this wave at O? Well, because these distances are the same, these two waves are going to constructively interfere, because basically they're in phase. And if they're in phase, when you get a maximum amplitude, you'll get two maximum amplitudes. So you're going to get constructive interference. Constructive interference. So if you get constructive interference at point O, you're going to get two amplitudes. You're going to have the amplitude thanks to X and the amplitude thanks to Y basically added onto each other. Now, if intensity is proportional to amplitude squared, what happens if you double the amplitude? 2a squared. Well, that's the same as 4a squared. Okay, we need to deduce now in this third question that no sound is selected at P. Okay, so if I draw this out again, okay, so I've drawn it out here. We have source X and source Y, and at this point, at this point, the question asks, why is there no sound detected? Oops, lost it. Okay, there's no sound detected at this point, obviously because we have destructive interference. So we're going to have to now somehow prove that. From what you know, destructive interference means there is a path difference of a wavelength over 2, which means that this wave must be half a wavelength, or a factor times half a wavelength less than this one. So how do we work this out? How do we prove that the path difference is lambda over 2? We need to find this length and we need to subtract this length from it, and it's got to be either wavelength over 2 or some multiple of that, or 1.5 waves or 2.5 waves, something like that. So let's try and work out these lengths. I'm going to draw some grid lines to try and help us calculate this length and this length, okay, because we're going to be using Pythagoras. So I have the distances added on. What we've got here are two triangles. Let me show you. You have one triangle here, a right angle triangle, which is going to help us find this length A, okay, and then you have another triangle here, okay, and that should help us work out the length of B. So if we work out those distances, let's start with line A. We have a distance 4 along here, and this distance here will be 1.6 minus 0.75. Okay, so that distance there will be 1.6 minus 0.75. Okay, So we can use Pythagoras. So we have here 0.85 is this distance, and if we use Pythagoras, 0.85 squared plus 4 squared would give us that distance a squared. So the value of a equals 4.09 meters. Okay? If we now work out this triangle, or this length b, we do the same, but this time this length, okay, so this length would be 1.6 plus 0.75, okay, and again, if we square that and add that to 4 squared, it will give us length b squared, and you should get a value of 4.64. Okay, now need a bit more space. Length of b minus the length of a will give us our path difference. So the length of b, 4.64 minus 4.09 gives us approximately 0.55 meters. And if you look at the wavelength given on the previous page, it's 1.1 meters, and this is half of that. Okay, so we've definitely got destructive interference, because this is half of this. It's a lot for a few marks.